Welcome to Study Loop.
Now we have a collar riding on a circular rod or semicircular rod, and there's a spring attached to the collar and also to a point um, on attached to the ground, and the semicircular rod is now in the vertical plane, so we have to be careful and we have to make sure we account for changes in gravitational potential. So this is kind of in three dimensions, so it's easiest to write uh, position vectors. And I use point C as the origin, as indicated in the book. And so then point A we have, and point B we have, and then point D we have the position to all of those points, the position vector. We're told the mass of the slider is a ½ kilogram, and the spring force, the spring constant, is 320 newtons per meter. And the spring has an unstretched length of 200 millimeters. And so we're told that at position B, the slider is, the collar is released from rest, so that the kinetic energy is 0 there. The potential energy at B has potential energy from the spring and from gravity. So YB is just the Y component of R sub B. And with a length from A to B, we can figure that out because we know the position of A and with the position of B, so we can subtract those two and find the magnitude, would be the length. And so we have this, and then at C again we have the potential energy. There's no gravitational potential at C because Y of C is 0, and we can figure out the length, the distance from A to C, so the length of the spring, because we know point A and point C. And then we have some kinetic energy at that point. And then at point D, we have, again, the length of the spring we can figure out because we have A and D. And we have some gravitational potential again. And at point D, we have Y sub D is 150 millimeters. And then we also have some kinetic energy there. So the first question was to figure out what the velocity at point C is. So the energy at C must equal the energy at B, so we know that T sub C equals the difference between UB and UC. And that gives us an equation for VC, and we can plug in and we get that that's 2.92 meters per second. Now they ask what the force from the rod on the collar is at point C. So we can write Newton's laws for the collar at that position. So the mass times its acceleration must be the normal force from the rod on the collar plus the spring force minus the weight. So again, we can solve for the normal force, and in the y direction at that point, the acceleration is vc squared over r in the positive y direction, because it's going through this circular arc. And then, so we get that in that case, ny is 33.3 newtons. And in the x direction, there's no acceleration in the x direction. There's a spring force. There's no weight acting in the horizontal direction. So n sub x must just be equal to the x component of the spring force. And we can figure that out because the x component, the spring force, I didn't write it here, I'll just write it here. The spring force vector equals k times the length minus the initial length. Also at point, say at point C, so the spring force at point C is the spring force at point C here is, and the direction is from A to C. So we can figure out that unit vector there, and because we know points A and we know point C, so we can figure out this unit vector, so we can figure out the direction of the spring force and take the x component, and we get that that is minus 33.9 newtons.